would like to give you a short tour of the ion table so that you understand how the ions are organized. That way you can maximize the potential of the table. Some of the information that is on this table can also be found by using the periodic table. The cations can be found on the left side of the table. Remember, cations are positive. Most of the cations are simply metal atoms that have lost electrons. The only exceptions are hydrogen, which is a nonmetal that most commonly forms a cation, and the lone polyatomic cation, ammonium, NH4+. On the far left, I have organized the metals that have consistent charge. The alkali metals all have a +1 charge, and the alkaline earth metals all have a +2 charge. You can get that same information from the periodic table. I also placed the transition metal exceptions on the far left. These are transition metals that only have 1 charge. So when it comes to naming ionic compounds containing these cations, you do not need to use Roman numerals. Those exceptions are aluminum, silver, and zinc. Transition metals occupy that central block on the periodic table. Transition metals are unique in that these metal atoms could lose different numbers of electrons to form a cation. For example, lead atoms could lose either 2 electrons to form lead 2+ cations or 4 electrons to form lead 4+ cations. The charge or transition state of the specific transition metal cation is indicated by the use of the Roman numeral after the name of the metal. Lead, Roman numeral 2, means lead 2+. Lead, Roman numeral 4, means 4+. You will notice not all of the transition metals have made it onto the ion table. That's because I only used the most common transition metals a student will work with in a chemistry class. These colors you see in parentheses are in reference to the color of the solution formed when these ions are dissolved in water. For example, copper-1 ions form a blue solution when dissolved in water. On the right side of the table, you will find a list of anions. You will notice most of the anions are polyatomic ions. Remember, polyatomic ions are those that are made up of more than 1 atom. I organized the anions alphabetically by central atom. The central atom is usually the first element listed in the formula of the polyatomic ion. These contain bromine as the central atom. These are carbon containing. These have chlorine, all the way down to sulfur containing anions. My thought was that organizing the table in this way would make the ions easier to locate. Let's just look at one group. Here is a list of the nitrogen containing anions. Notice the first anion listed is not polyatomic. Nitride has a 3- charge. This same information could be found using your periodic table. The remaining anions listed are polyatomic. NO2- is nitrite, NO3- is nitrate, and CN- is cyanide. Notice that I also listed cyanide under the carbon-containing anions. I want things to be easy to find. When searching for elements on the ion table, try to remember a few things. I will explain using an example. Let's say we want to determine the formula for calcium nitrate. First, we would have to find calcium. Well, if the name of the element is used, you should know you are looking for a cation. There's no change to the end of the name. So focus on the left side of the table and look for Ca. Here it is, Ca2+. Now you have to find nitrate. From the beginning of the term nitrate, you should understand that the ion is nitrogen containing. From the ending, you should know it is polyatomic. The ending is IDE for just the element nitrogen as an anion, nitride. Most polyatomic ions have an ATE or ITE ending, like nitrate and nitrite. Notice I said most because cyanide is a common example of a polyatomic ion using an IDE ending. So is hydroxide or OH-. Hopefully this little tour has helped you better understand your ion table. Knowing how to use this table will help you tremendously when naming ionic compounds and coming up with the formula of ionic compounds.